The broadcast is now starting. All attendees are in listen-only mode.
On behalf of RBCS and software test professionals, we welcome everyone today to this webinar on testing Sherpas. I am Rex Black, president of RBCS, a worldwide testing and quality assurance firm serving clients ranging from small startups to Fortune 20 global enterprises. Since 1994, RBCS has been both a pioneer and leader in quality hardware and software testing. RBCS has offices in the United States with partners around the world. We deliver insight and confidence to our clients. We help them get quality software and hardware products to market on time and with a measurable return on investment. We have a team of international consultants that deliver customized training, consulting, and outsourcing services for companies that are looking to improve their test and quality assurance practices. RBCS has helped hundreds of companies reduce development and support costs while assuring the best quality products are delivered to customers. I am the author of Pragmatic Software Testing, Advanced Software Testing Volumes 1, 2, and 3, Foundations of Software Testing, Critical Testing Processes, Managing the Testing Process, and Fundamentos de Pruebas de Software, the first book on the ISTQB certification in Spanish and the first book in any language aligned with the 2011 Foundation syllabus. I am also the author of 2 upcoming ebooks. One is tentatively titled Testing Metrics, Measuring Product, Process, and Project Quality, and the other is tentatively titled Improving the Testing Process, a value-based approach to assessing and enhancing testing maturity. I hold a degree in computer science and engineering from UCLA, and I am the past president of the International Software Testing Qualifications Board and the American Software Testing Qualifications Board. We are presenting this webinar in partnership with Software Test Professionals. If you haven't checked out their association website yet, take a look, www.softwaretestpro.com. Attendance at today's webinar does earn PMI PDUs. I would like to thank Ken Young for reviewing the material for PDU status. Visit www.pmi.org to claim the PDUs. Use activity code SHERPA101, SHERPA 101. That's PMI PDU activity code SHERPA101. RBCS's provider ID is 2986. PDUs are available for live webinar attendance only. Before we start the presentation, some housekeeping notes. If you have any questions, submit them at any time via your webinar interface. Please note that I do not look at the questions until the presentation proper is ended. So please don't be frustrated if you post a question 5 minutes from now and it doesn't get answered for another hour, because it could be that I don't see it until well, it will be that I won't see it until the Q&A session starts. You do not need to ask about how to register for the free e-learning drawing. Just by attending today, you are automatically registered. Do check your email over the next couple days. We'll watch that spam filter because you do have a limited amount of time to respond if you are the winner. If you are having any sort of problems with the with getting on this webinar, common problems are either browser related. There's compatibility issues sometimes with the browser, so try using a different browser. Try using Chrome if you're having a problem with IE, or use your earlier version of IE or something like that. The other problem can be audio. To fix audio problems, you just need to play around with your audio settings and see if you can find one that works. Generally, it's some kind of volume problem when people have it. Excuse me. The other problem that people have is not being able to get access to this at all. Of course, you're not hearing me if you're having that problem. That is usually a firewall issue and can only be solved by using your own personal computer or having your company turn off the firewall, or at least grant access to GoToWebinar. Some companies don't like to do that because it does download a piece of Java code onto your PC, and that can be against company policy. As a last resort, if you cannot get to the webinar online, what you can do is download the slides from the basic library. Those are posted on the RBCS website, rbcs-us.com. And then go to the Resources tab in the middle and pull that down, and then navigate from there to the basic library. You'll find the slides posted at the very end, PDF format. You can download them and then use a telephone to connect and just follow along with a PDF version of the slides. And of course, you don't need to ask for copies of the slides because, as I said, they're available for download off the website. So I hope you enjoy this free webinar from RBCS. We do these free webinars as a service to the software testing community because at RBCS we are not just for-profit company. So today's presentation is on testing Sherpas. If you're not familiar with that term Sherpa, you might be familiar with the fellow shown here. This is Tenzing Norgay. Tenzing Norgay was the Sherpa, which is to say he was the Tibetan guide, mountain climbing guide for Edmund Hillary when he climbed to the top of Mount Everest. So a good independent test team is something like a Sherpa. It can guide the organization to better testing and higher quality. So what are the advantages of independence? What are the questions associated with an independent test team? Well, first, when we're talking about an independent test team, what is it? What are the objectives that it serves? What goals, services, benefits should it provide? How should it be organized? What kind of strategies are applicable in independent test teams, testing strategies? How do we know that we're succeeding? What are the key process indicators or key performance indicators or KPIs or whatever you want to call them? Different organizations call them different things, but basic idea is how do we measure success? What are the risks? How do we manage the risks associated with that? And what's the business case for going to all this trouble of having an independent test group? So in this in the next hour or so, we'll go through answers to these questions, and we'll look at a few case studies to illustrate those answers. So first off, what do I mean by an independent test group? Well, I'm talking about a group of independent professional testers and test leads managed by either a test director or a test manager sitting above them, depending on the size. The larger groups will have test directors and test managers reporting to them and test leads reporting to them, and individual contributor testers working underneath the leads. Smaller groups might just have a manager managing a handful of testers. So part of it is professionalism. What I mean by professional is we're talking about trained, experienced testers. These are people that's what they do is test. They don't test in their free time. They don't test as part of doing other jobs. They are testers. As I said, managed by a professional test manager of some sort or test director. Now that the independence comes in terms of reporting, so reporting some level of management above the project team. The important thing is that the person that they report to is not someone who is entirely incented by schedule and budget targets. If that's the way that person's compensation, bonus, annual performance evaluation, etc., is done, then that person will have difficulty in providing support to a group that needs to be focused on providing an independent assessment of quality, which is certainly what we would want out of an independent test team, is that they would be a unbiased voice reporting the truth about what the quality of the software was at any given moment in time. Now, of course, there's right ways and wrong ways to do that, and I'm not saying that independence provides a license to offend, but it does need to be something that someone can speak the truth in a diplomatic and objective and respectful fashion, and not have to worry about consequences for them. And then finally, independent test groups should have their own test environments and often their own test tools. Now, sometimes this is not true, but in that circumstance where that's not true, that does tend to be a problematic situation. Sharing environments with development teams and so forth is often problematic in terms of the meaningfulness of the results, the ability to get work done, etc. So let's start with a case study here. It's a large banking organization, a client of ours in Australasia, has an independent test group. And this is a very effective and very efficient group. We've done an assessment of them years ago, and they continue to measure based on the metrics or KPIs that we came up with for effectiveness and efficiency for them, and they are quite good. They are responsible for the system integration testing of systems before they go into the bank's data center. But it also they provide support to other sort of testing and QA functions. So there's testing and quality assurance activities throughout the life cycle with the support of the independent test group. And in the case of system integration testing, it's that they're actually doing it. So let's take a look at how that works. Now this diagram, let me get a highlighter here. This diagram shows their release process, and the testing activities in the context of their release process. They follow what's called a train, sometimes referred to as a train release process, which is that the train, which is the release into production, leaves the station at regular intervals, and whatever's ready to get on the train, in other words, to go through the final testing levels and be promoted into production, is put onto the train at that time. If it's not ready, then it's put onto the next train. That's the meaning of the word train here. And so what you see here, we've got 5 projects that are in flight, and this is simplified. There would typically be more than 5 projects in flight at one time, but just to keep it simple. These projects can be following either an agile or a sequential life cycle model. Just to keep this diagram simple, I haven't shown the iterations in the case of ones that would be following agile models, but it would be the same kind of thing, except that the same project would be dropping releases into multiple trains, if you will, dropping software into multiple trains, one after the other, as more and more features were added. But conceptually, same deal. So what happens now is there's specifications, either formalized types of specifications as in a more traditional lifecycle model, or user stories. Either way, those will be those requirements, specifications, and other specifications, if they're design specifications, for example, those have to go through a review, and that review is led by the independent test team. So that's happening here. Then there is the development and unit testing, and so this is done by the developers, individual programmers. If applicable, there will be component integration testing happening in some simpler projects. That's deemed not to be applicable. That's done by programmers and testers within the development team, who will not necessarily be professional testers. They could be people who are working sort of part-time. They've been delegated the responsibility of being a tester. And then finally, there's system test, which is done. That's mandatory, and that's done by the development test team. But again, there's support available from the independent test team for these different activities, should it be needed, should it be requested. Now, there's exit criteria from system test, which determine whether you're ready to, quote-unquote, catch the train. And as we see here, we have Project 1, Project 2, and Project 3, all of which make that. And then they drop in here for the May release. And then this is the point where system integration testing is being carried out for all the existing stuff that's in production, because they have to do interoperability and sociability testing, plus the new stuff that's being added from projects 1, 2, and 3. That's done by the independent test team. They also use staff augmentation, insourcing to bring in certain skills and volume of people. And then they have in the system integration test environment, the security team comes in and does security testing. They're a separate group. And then UAT is done by the users, typically expert users, and that's also in the test environment and supported by the independent test team. And notice that there can be parallel things going on at once in this model. In some cases, there is not parallelism. In other words, there's not two separate test environments. There's just one. But you can also, in this model, have two separate test environments, and then you can accelerate things by having multiple trains going at once. Now, obviously, in that case, you have to be careful about getting in stuff that's prospective for the releases. But anyway, this process works quite well, and the intricate stuff associated with release management and so forth is all carefully coordinated here as well. They have very low defect rate in production. I think their defect detection effectiveness for the system integration testing tends to run in the 99% plus range. Now, I talked a little bit about what the group's doing in terms of its effectiveness, and I mentioned finding defects and how effective they are at that. So that's a typical objective for an independent test group, is finding defects, and of course should be especially focused on the more important defects. It's all well and good to find a lot of defects, but to find a whole bunch of trivial defects and then have important defects surface in production is bad. Techniques like risk-based testing, which I'll discuss a little bit later, are things that can help you make sure that you're focused on the important defects. Another typical independent test group objective is to build confidence in the system, that it will operate properly under certain tested circumstances. Obviously, we can't prove that it will work because that's not something that's possible in testing, but we can definitely build confidence that certain things that have been thoroughly tested are unlikely to fail in production. Reducing quality risk to an acceptable level, including the regression risk, is another typical objective for a test group. The risk-based testing, again, is something I'll discuss, and also the use of automation to tackle regression risk is another important element in the strategy. And then finally, here on this list, the providing unbiased information about quality, where we stand. I mentioned that before. Also being able to provide information about how complete the testing is, in terms of what was covered and what wasn't, what's passing and what fails, what risks remain, so forth. There we go. So here's an example of objectives. This is for a client of ours. We helped them define a test policy document, and in that test policy document, one part of it, we had the different defined test levels. You see, let me get the spotlight up here. Unit testing, component integration testing. We have component integration testing with two. So there's two owners here. I'll explain that in just a minute. It's system integration testing, and then we've got beta testing. So development has a piece of this, QA has a piece of this, the customer has a piece of this. So we've got well-defined test levels and ownership. Notice that with the unit testing, we've got some objectives here and sort of policies. And then we've got component integration testing, more defined objectives. This is the development piece of it. Now, notice that the QA piece of this early QA validation of completed features. So in other words, they want to participate in component integration testing to get a sense of what's coming their way. And here we have the detecting bugs, reducing risk, building confidence objectives in use cases and end-to-end scenarios, and then also user workflows shown there. And then we see betas, looking for bugs just related to customer deployment. Obviously, you don't want your customers finding a bunch of bugs that could have been detected earlier. Managing the risk of customer business requirements not being met and demonstrating readiness. So we have clearly defined objectives here for the different levels and the different owners. We can measure whether these things are happening and whether the process is living up to what's desired. And we found this to be quite important, that when you have independent test groups that don't have defined objectives and there's no real solid way of measuring whether they're doing what they're supposed to be doing, you get a lot of subjectivity about, well, is the independent test group successful? Are they adding value? And people have different opinions. The opinions aren't based on facts; they're just based on impressions. So having these defined objectives and having the work carved up like this between the different participants in the independent test group, in this case called the QA group, is really very important. What does the QA group do versus what do the other groups do? What are the objectives of those activities and so forth? Very critical to successful independent test teams in my experience. Now, another thing that I think is very critical to the success of an independent test team is this concept of providing services. So an independent test group does not build deliverables. They're not like a development team. And so, what do? Well, they provide a service. Not just a service, they provide a range of services. So very important to understand who the stakeholders are and what services they are looking to receive. We see this a lot, not infrequently, a lot more than we'd like, I guess, with our clients, where you've got independent test groups. They haven't really thought hard about who all of their stakeholders are and who they could be providing services to. And so they're sort of sub-optimizing the value that they're delivering to the organization by doing that. Not sort of, they are sub-optimizing. If you have not identified the stakeholders who can receive valuable services from your test group, then it's a pretty safe bet that you're not delivering all of the value that you could be delivering to the organization. And from a purely political standpoint, you've got people who could very well be supporters of your group and supporters of you as a manager if you just connected with them and figured out what services you could provide them. But since you haven't, they might say, well, testing could be valuable to other groups. Testing adds no value for me. That's not a good place to be as a tester, because the more people that clearly perceive the value that a group adds, the less likely that group's budget is to be cut and headcount to be cut and so forth. So know your technical stakeholders, people like programmers and development managers, database architects, and so forth. Know your business stakeholders. Very important. I think people, especially well, in some Agile teams that we've looked at, maybe are more aware on the technical stakeholder side, less aware on the business stakeholder side. I think that's a mistake. I think you want to make sure that you've identified as a test manager both your business and technical stakeholders, and who are those people and what services can we give them? How can we help them out? So just to go back to the Australasian test group and what services they were providing. Well, they were leading the requirements reviews, as I said. They were supporting system testing and, if requested, unit testing and component integration testing as well. They were performing the system integration testing. They were supporting the test lab, including use by the security team, for example. They were supporting UAT and providing the environment for that, supporting the users in doing it, and they developed and supported automated tests that were used for regression testing and performance testing. So they had clearly identified services, and they also regularly surveyed their stakeholders. They had identified their stakeholders. They knew exactly who they were, and they knew which services were of value to them, and they would survey them and say, how are we doing? What can we do better? That's a very powerful tool, that survey approach. It's if you haven't tried it, if you haven't tried that, having regular conversations with your stakeholders about what you're doing well and what you're not doing well and how you can improve what you're doing, give it a try. You will be pleasantly surprised at how valuable that exercise is, and how much, and not just in terms of what you learn about what you can do better, but also the change in the degree of respect accorded to your team will be phenomenal because of that. So not only will you become better through that exercise, but almost as importantly, you will become perceived as better, and any differences between perceptions about how good you were that existed in the past and how good you really were will go away, and that can be a real problem, because we see that with clients where test groups by various objective measures are indeed doing a fairly good job, but the perception is these guys are zero value add, obstacles, overhead. So this starting that conversation is part of how you make that misconception, misperception go away. Now, we have organizational options that come up when independent test groups that are important to be aware of. Typically, there will be projects or programs underway, and at various points, and ideally, of course, at the very beginning, there will be a need for testers. At various points, that need can increase based on needing to go from more senior testers to individual contributors who are focused on running tests. So they'd be kind of a going up and down sometimes in terms of the level of assignment, level of resource required on a project. In some cases, not. Like, so for example, agile projects, generally someone's going to get assigned to be part of a team, one of the agile teams, and they'll be on that for some extended period of time. Best practice is that they would be on as long as that project was active. It wouldn't be shuffling testers in and out of the tester role in the agile team. Now, in some projects, and like a traditional life cycle model, that you might very well have people coming on and coming off based on what phase the project is in. So that's something you have to be aware of, is how are people working? Is agile versus traditional V model type of approach? Another wrinkle is do you need to be able to provide additional resource on a sort of a as needed basis? Are there going to be peaks in load, and if so, where do you want to bring that in from? Skills, what skills are needed, or is it a case that you don't want to have a specialized team, you want to have a more generalized team? So a number of things to consider here for your organizational options, and having a good fit here organizationally is key. Now, just to expand on that specialized versus generalized here for a moment. So the specialized approach, what you would have is testers who had specialties, special skills and they get put on a project based on the needs of that project. They might be serving multiple projects, coming and going as needed. This is an approach that can work, obviously, in an agile type of environment. This by itself would probably not be what you would want, because you've got some of the team cohesion issues associated with people coming on and leaving and so forth. But it might be something that could augment the other existing, the assignment of an individual onto an agile team. So in a specialized team, what are the advantages? What does this offer to you? Well, people are very specialized, so the effectiveness is very high. Tom DeMarco and Tim Lister's book, People, where they talk about the difference between the most qualified and the least qualified person doing a task is typically an order of magnitude in effectiveness, however you would want to measure that effectiveness. So 10 times better, with the median person, the average person, being about 2.5 times less good than the 2.5 times less good. Let me put this the other way. The most qualified person not only is 10 times better than the least qualified person, but they're 2.5 times more qualified than the typical person, the average qualified person. So you've got a lot of real firepower, in a sense, in this kind of approach, and it's very flexible. You're able to move people around as needed, and the expertise is, as I say, very high. And the effectiveness is very high, but it can be problematic with other managers. So, for example, as I said, if you're in an agile world, this is people might be jumping up and down saying, "Well, that's not agile. You can't be pulling people off the project, putting them on other projects." The other thing that can happen is that you can get overbooking and underbooking simultaneously. So, in other words, you get multiple projects that need particular skills, and you've only got so many people with those skills, so those people are overutilized. At the same time, those projects do not have demand for other skills, and yet you've got people with those skills, so they're underutilized. So effectiveness is high, but efficiency might be a little lower. Generalized teams are sort of the other way around. So generalized team, what you do is you strive to have testers who are as general purpose in their testing capabilities as can be. Now, that's obviously an idealized situation, perhaps, versus with something that's actually practical. But as you grow the skills of people in the team, your goal there is to increase the homogeneity, the uniformity of their skills, versus in a specialized team where your goal as you're growing people's skills is to make people more and more expert at whatever their chosen area of expertise is. In a generalized team, testers would stay on a project until their role is complete, until they're done, and this can go on, for months or years, potentially. Obviously, this is the typical model of an agile methodology, or with an agile methodology when you have an independent test team, is that the people are ostensibly part of the independent test team, but they are in a sort of dotted line reporting structure to the sprint team that they're part of. Excuse me. It's allergy season down here in Texas, and so everybody's coughing. So, the advantages of this, well, it's in terms of focus. If you have testers that really, need a structured environment to focus, they can't, when they have a lot of different priorities going kind of all over the place, they tend to kind of get lost. Those people do not work well in the specialized environments many times, but can work in this generalized environment where they get assigned on a project and that's what they're supposed to focus on. It's also going to be more efficient because you're not going to have that overutilization at the same time you have underutilization, and people get assigned, they're on a project, they're on the project, and as long as the estimation was done properly, then there should be sufficient resource for each project. Now, as I mentioned before, the effectiveness is not going to be as high in this situation, right? Because remember that the most qualified person being 2.5 times more effective than the average person. Well, here you're going to have a lot of people that are sort of average across all their different skills. Now they have many skills, but they're not very skilled in any one of those skills. If that makes sense. So yeah, you're not going to be quite as effective, but your team will be more efficient. Now another potential downside of this is what I'm going to refer to here as going native, which is testers in an independent test team need to have that unbiased, objective viewpoint. Sometimes, if there's not good guidance from the test manager and the other people who are in the independent test team on how to maintain that perspective within this embedded situation, then that objectivity can be lost. So it's something that you have to deal with or manage as a manager. Here's an example of organizational structure. This is a somewhat specialized organizational structure that we used for a project with a client. We were testing internet appliances for them, and so what we had is we had two teams. Let me get the highlighter up here. We had a server-side team. So there's a test engineer who's serving as a lead there, supported by test technicians reporting to him. And his role is to do things like performance testing and reliability testing and other kinds of functional testing on the server side. And then we have another engineer, same kind of structure. Their focus is on the client side, testing functionality and so forth on the client side. Now, in addition, we had a couple other specialized roles. We had toolsmiths. See these guys down here. Their job was to build test tools. That's what a test toolsmith does. They build specialized testing tools. We didn't have a lot of commercial test tool options available to us in this project, so we ended up building a lot of stuff, often in case of bits and pieces left over from the developers who were building very good automated unit test harnesses. And we also have a usability engineer. See here, and we're here, and this person will be out in the field doing usability testing of the user interface. Okay, I mentioned strategies, testing strategies. So there's the objectives. There are the objectives that you're trying to accomplish with your testing, and I said it was important to have those clearly defined, and a way of measuring those measuring your effectiveness of those with KPIs needs to be defined, and more on that in a minute. But okay, so there's what you want to accomplish, and it's good to know what you want to accomplish, but you also have to have a strategy for how you're going to accomplish it, right? I mean, you can have any number of goals, but if you have no thought out way by which you're going to achieve those goals, then the odds are very good that you will not. So good independent test teams have strategies that are a blended strategy. They look at they use a number of the strategies shown here on this slide. Let me just go through some of these. So analytical strategies that involves early involvement in each project or each iteration, analyzing the requirements, analyzing the risks, deciding what to test based on that. Model-based testing based on things like business models or performance models, web log information. You've got some sort of model of how the system works. There's methodical testing. You have some sort of standard pattern. So examples of this are like failure-based or checklist-based testing. So a lot of organizations, as part of their manual regression testing, will follow a methodical approach. Also for user interface testing, they can have a checklist of, these are the important things to look at from a UI point of view. Process or standard compliance strategies. Some organizations are very much, part of the strategy is we follow the IEEE 829 standard for test documentation, or we're working within an agile environment, so we follow the rules of the road, if you will, for Scrum and extreme programming and so forth. Now, so reactive testing strategies. This is where you respond to the system as it's actually delivered to you. So things like exploratory testing and fault attack testing, such as described in Whitaker's books. Those are forms of reactive testing. Directed testing. This is a test strategy which makes sense in certain cases. This is where some outside group, organization, individual basically tells the test group what to test. Typically, independent test groups are not going to follow a directed strategy, or at least we don't think, associates and I don't think that that's a good sign, because part of the value of the independent test group is being the professional testers that know how to determine what to test. Directed strategies are very useful when an independent test group is going to retain a testing services provider, outsourced testing provider, and so forth, to come in and do testing for them, or to do the testing externally, because the independent test group should be able to direct that group as to here's what you are to cover. And then finally, regression-averse strategies. These are something that we would tend to see independent test groups following, and that's reusing existing tests to do regression testing, especially when you see a lot of automation of existing tests, and you're part of the strategy is regression averse. So as I said, a good independent test team will blend these different strategies together to come up with an overall strategy that's a good fit for their organization. Less successful independent test groups typically pick and rely upon a single strategy. So we'll see independent test groups that all they do is reactive testing. I remember one time asking this test manager, well, what are you doing? What's your strategy? He said, well, we just do guided exploratory testing. Okay, well, that's good at finding certain kinds of bugs and providing certain kinds of benefits, but typically it will not achieve all of the objectives that I discussed earlier. Similarly, we've seen clients where all they do is pure analytical requirements-based testing. That, again, strengths and weaknesses, but you take those together, you do things like risk-based testing and requirements-based testing and reactive testing and model-based testing and methodical testing, process compliant testing where applicable, and audit and reactive testing as a component. That tends to have the highest level of effectiveness across all of the different objectives that you could measure. Excuse me. So on the Internet Appliance Project, which I had mentioned before, we did analytical risk-based testing. So we had analyzed the risks to the quality of the system as part of our planning process. We received requirements. We analyzed the requirements and developed tests from those as well. We had models, actual automated statistical models using a tool called Hyperformix for performance and reliability. And our automated tests were developed in alignment with those models so that we could double check them. We did exploratory testing, a few hours of that a day done by the more senior testers, and we had some standard tests that we ran against each software release, and some of those were automated. So as I said, this kind of blended approach using a lot of different strategies does tend to be the most effective and efficient approach when compared to a sort of a monoculture, if you will, monostrategy, which it should be really no surprise to anyone, because that's true in a lot of different settings. Now, key process indicators, being able to measure your success. So I talked about the importance of identifying your objectives. So that's the first step. Know what you're trying to do. You don't want to just say, oh, here are a bunch of things I can measure, so I'm going to measure those and measure myself against them. Well, how do you know that those are important? So you want to have the objectives. You want to talk about, what do it mean for me to be effective at this objective, efficient at the objective, elegant or satisfying in the way that I achieve the objective. And then based on those those questions, come up with metrics or if necessary, surrogate metrics for the different questions, and make sure that you can measure them, and then you can set goals for each metric. So you say, okay, I've got defect detection effectiveness, for example. What percentage of defects are found in system integration testing before we go into UAT? Maybe you set a goal for that at 90%, which is, a pretty good goal. Benchmark where you are right now, or baseline, excuse me, where you are right now. Maybe benchmark against some outside organizations in your field. What's the average for other groups in my same industry? Use that to then say, okay, here's my goal, and with these KPIs in place, periodically, once a month or so, you measure success, maybe once a quarter, once every 6 months. If you find that you're falling behind in some area and failing to achieve, then you need to go out, figure out why, and implement improvements that will bring you up in that level. If you decide that you want to improve, then you look at what would be the most valuable to the business. What service, if it were improved, would be the most valuable one, and then go ahead and beef that up. So these should be tools that you use. You need to think of these kind of metrics as like the gauges on your dashboard in the car, right? You use them to help you guide. They don't become the be all and end all, right? It's not like, oh, my goal is to hold the engine at 2,000 RPMs. No, you're looking at that as part of the bigger picture of, am I successfully driving the car? And that's the same thing here with the KPIs. So here's a case study from a client where we went through and we put together some KPIs. So let's take one example here. These are KPIs for the test group. Get that out of the way. So the first one here is the strategic objective. Strategic being it's visible to the broader organization, and how effective are we at covering the risks. That's part of the executive dashboard. So we want to have risk ratings, requirement by requirement, then that's linked to the test results. So our metric there is going to be the risk reduction effectiveness. We're going to look at percentage of risks covered by tests, and have those tests, are those tests being run? We have another strategic objective here, how much risk remains. So this is a part of the management dashboard. Again, it's coming from that traceability of the risks. It's going to go to the management team. They're going to look at it and say, is this an acceptable level of risk or not? We're going to have a graph or table that shows the residual level of risk for that. So these are some examples when I'm talking about KPIs, what we would be looking at for how well we're doing. Okay, now independent test teams are not without their risks. There can be problems, and we have seen some problems that have arisen when these risks are not managed. So, say the top three problems, the ones that I would worry about the most, would be first, the developer abdicating their responsibility for quality. It's sort of, yay, we have a test team, so the testers will catch all the bugs now, so we don't have to do any unit testing, which then leads to actually lower levels of quality because code comes in such bad shape that the testers are overwhelmed by the number of bugs, and then that, end up having more defects in production, not less, which is of course not what you want. Isolation of the test team and the alienation from the test team by the developers. Perception that the testers are an obstacle. Excuse me. That's another thing that we've seen happen. Another thing that we've seen is that there's not a clearly defined business benefit, and so you get this sort of, well, the testers are very nice, they're trying to help, but there's really no value there. And these are all risks that can be managed. I'm not saying this if you have an independent test team, these are things that will happen. There are things that can happen if you as a manager don't take care to manage these risks and reduce them. So, some case studies. The case study of a problematic situation, these risks were not managed. So we had a client that had us come in and do an assessment, and they're really very much a what I refer to as the quality cop kind of orientation, or not just quality of the code too, is also sort of a process cop orientation of like they were saying, well, if you haven't done this and you haven't done that, then we're not going to test, right? And some of these things had to do with testing, but some of them really kind of didn't. It was just kind of, well, these are best practices that should be followed, but they're development best practices and really should be up to the development manager to enforce them, I would say. Now, to their defense, they were not doing this because they just made this up. Now, I have seen that happen. We just had a client recently where they had a director of QA who was in that process cop orientation, and because he said that's how it needs to be done. In this case, though, these guys had been instructed by the previous CIO to be process cops, but that had not been effectively communicated to everybody else. And then when the new CIO came on board, he didn't really want them to be process cops. He never really had a conversation with them about what exactly he wanted them to do at all. So they're sort of rogue cops at this point. They're with no badge and no mission, but they think that they've got one. So really, really bad scenario. I mean, we would talk to the non-test people, the stakeholders, and they would just say, we'd say, well, what's the value of testing? They say testing has no value. Testing is obstacle. Testing, they're just complete troublemakers, and do everything we can to get around them. You talk to the testers, and the testers would say, oh, those guys are completely clueless about quality. If it weren't for us being here, then God knows what kind of garbage would get thrown into the production environment. It'd be a disaster, right? So these guys are total loggerheads. There's no cooperation. There's no shared vision of what they're supposed to be doing, why they're doing it, what the value is, and we gave our report and basically said, by most objective measures, your testing is pretty good. Your testing is above average in terms of its effectiveness, but we can't really tell you how to make it better, because one of the prerequisites for making it better would be collaboration between the developers and the testers. Everything that needs to be done to improve the testing now involves collaboration, and that simply will not happen with the current management team on both sides. It wasn't just the testers; it was both sides, and so they ultimately, we heard about 6 months after we did our assessment that things just continued to deteriorate, and they decided to dissolve the test group and outsource all of the testing. And it was a sad story, but it certainly was not a surprise that outcome occurred. Now, just to contrast this and to demonstrate what I was talking about, this doesn't have to happen. Our Australasian case study that we've been going through, they are aware of and they manage these risks. They support the developers' testing. They measure defect phase containment, say, okay, here's the number of defects being introduced, detected, and removed in each part of the life cycle, so here's some things that we can do to improve quality. But it's from a support point of view. It's not from a, you guys are horrible and we're here to make you look bad. It's more, you guys are great and we're here to help make you even better. As I said, they regularly survey their stakeholders. If any issues come up in that survey process, they immediately address them. And they have, KPIs, as I mentioned before, and measurable business benefit. They're able to report that to people. So these guys, in contrast to the other example that I gave a moment ago, very much supported by the organization. When we talked to people there in the assessment and asked, what's the value of testing, everybody had something good to say about how valuable they were. Now let's look at business case here for a moment. Now, talk about, everybody having something to say about how valuable the test team is. There's quantifiable value and there's qualitative value, and they're both valuable. It's just the quantifiable one is, of course, one that you can measure, and qualitative is more intangible, but might be to some people even more important than the quantifiable values. So in terms of things that can be measured, finding important defects that need to be fixed, as I mentioned, that's an objective before, right? Sometimes just finding defects that are deferrable don't necessarily need to be fixed, but we'd like to know about them. That can be a value for example, the technical support or help team, because now, they can have these in their knowledge base, and ideally there's workarounds that are applied, and that can be used to basically help users out of a rut if they call up and say, hey, I've got a problem with this or that or the other thing. So that can be another value that is quantifiable. The reduced risk associated with running tests, also a big value that's delivered, and one that can be measured. And the value of the information itself can indeed be measured to some extent. So those are all things that people want from testing. You talk to other people and they might not mention those things, or might be more focused on, improved reputation for quality is really what we want. We want to have a reputation of being the highest quality software vendor in our market, or something along those lines. Or, we want to have a reputation with the business that when we put something into production, it works. Smoother releases, another thing that people can look for out of the test team, especially supporting earlier testing. Increased confidence. I remember one assessment interview being told by a project manager with a very colorful story about a nightmare that he had, that the reason that he really valued the test team was because they allowed him to have confidence when he went into production. In some cases, legal liability, compliance issues. We've got clients that are FDA regulated. There are certain things they simply have to do, and that can be the highest, most important value. And then in some cases with safety critical systems or mission critical systems, and reducing the likelihood of a loss of mission or loss of life is something else that can come up. So, when you talk to the stakeholders, be open to the fact that there's going to be a lot of different values. Some of them you might be able to measure, some of them you can't. Now, in terms of the defects, finding defects, that tends to be the easiest one to measure, and there's a technique called cost of quality that is one that we try to use quite a bit in assessments. It's about the easiest one to use, and it's the most widely accepted, I guess, of the quantifiable values. So if you want to get a measure of, what's the value of testing, how much money am I saving the organization as a testing organization, cost of quality is what I'd recommend. Now, I've done entire presentations on cost of quality, as those of you who are regular listeners to this webinar will know. I'm not going to try to do that all in the next 2 minutes, but basically cost of quality, you've got 4 quality cost categories. Cost of prevention is money spent to try to avoid having defects in the first place. Cost of detection, which is money spent to have some sort of detection system in place, such as testing, but not on finding bugs. The costs of testing associated with finding bugs are the costs of internal failure. So testing budget is partly cost of detection, partly cost of internal failure. This varies, but it's not unusual to find that it's about 50-50. About half of the test budget is cost of detection, in other words, money you'd have to spend even if you didn't find any bugs, and the other half are costs of internal failure. And the cost of external failure is what happens when you've got bugs in the field in production. And generally what happens is that the cost of external failure is so much higher than on a per bug basis than the cost of detection and internal failure excuse me, I just had something weird happen here. The costs the costs of detection and internal failure are completely covered by the cost of external failure. So here's a case study. Excuse me. This is for a smallish testing project that we did, and basically what I'm doing here is I'm going through and calculating the cost of detection on a per bug basis. That's what you see here. This is $267 per bug. These retest costs are costs of internal failure. That's regression testing and confirmation testing. So those go down here. So we've got internal failure costs associated with testing plus the development internal failure costs associated with bug fixes. So now I'm calculating the average cost per bug of internal failure. That's $833. So basically $833 plus $267 is $1,100. That's the cost to find and fix a bug in testing. And if we look at the external failure costs that were calculated for this project, you see that we've got on average $3,000 in external failure cost per bug, and that, by the way, is quite low. It's typically going to be a lot higher than that. So every bug we find and fix in testing saves $1,900, right? That's 3,000 minus 1,100. We found 1,500 must-fix bugs, so the net benefit of testing there's 1,500 by 1,900 is 2.85 million. We divide that by the net detection cost. That gives us our return on investment, which is a 700%, which is actually, you know, it's a huge number, and you might be thinking, whoa, wow, that's really amazing. Actually, that's fairly typical. There was a study done at the Defense Department that showed that the typical return on investment for testing was 800%. Now, we've seen this range kind of all over the place with our clients, but we've never seen it zero or negative. Testing always saves more money than it costs. If you're curious about this, there's a recorded webinar on this topic, and there's also an article on the basic library or the articles page on the website. I'm not sure exactly which, but look for the phrase testing ROI and you'll find it. And there's also an ROI calculator that's available there, a spreadsheet that basically this spreadsheet that will allow you to do this calculation. So if you want to give that a whirl, try it out. Okay, so to conclude and get into the Q&A session, as I said, we've got objectivity. One of the things that we get from an independent test group, people who will speak the truth about what their findings are. That can be connected to various objectives, and those should be well defined. You want to identify your business and technical stakeholders, identify the services that they receive from you, and talk to them about how to better that. That should be, of course, connected to your objectives, right? Your defined objectives should be connected to the services that people are receiving. Think about this issue of how to organize, specialized versus generalized. How to assign people, will people get moved around, understand your organizational options, understand your strategies, understand how those relate to the objectives. You should be able to have clear traceability, if you will, from here's my objective, here's the strategies that are supporting it. Also have KPIs for your objectives so that you can say I can measure quantitatively that I'm achieving these objectives, and people are asking you, what's the value of testing? What do you guys do? You can show them. You don't have to just tell them. Make sure you manage the risks that I discussed. That can be fatal if they're not managed. I gave you that example, and unfortunately, that's not an isolated example. I've heard many variations of that story that came down to there was some risk associated with having a centralized independent test group. It was not managed by the director, or VP or manager in charge of that independent test group, the independent test group was disbanded. Definitely measure your return on investment and be ready to demonstrate that to people. Be ready to show people that testing adds a lot more value than it costs, because the typical misconception about testing from non-test stakeholders is it's a cost center. And what you really need to be able to show is, no, we're a saving center. We're saving you money. Okay, so that concludes the presentation proper. I'll go to the Q&A session. Give me just a moment here to undock the question panel and get that up here. So you got a message from Abby from Software Test Professionals. Happy New Year, RBCS team. Just checking in. Good to see you, Abby. Thanks for your tweet help in promoting today's event. I had another nice message here from Chris. Thanks again, RBCS team. So hey, you're quite welcome. Thanks for coming. Let's see. So now I got a question from Stefan. Says, don't you think that in your model, and I think he's referring, I believe, he's referring to, oops, let me get it back here. It's a little difficult with the Q&A panel up. Yeah, this one. Says, don't you think that in your model, development test team tests, component test, and system test should also be done by an independent test team? So good point, Stefan. You're saying, you know, these guys here, right? I think you can make a case that that would be another way of organizing it, and that it would increase the effectiveness of those two levels of testing. I mean, that would definitely be true. So if the independent test team were also in charge of system testing, would system testing be more effective? I think that's definitely true. If they were involved in the component integration testing, working with the developers on that, would the component integration testing be more effective? Yes, it would definitely. It would be. In this case, I mean, to some extent, I think that might be solving a problem that doesn't really exist, because apparently these guys are good enough. You know, as I said, the defect detection effectiveness of the system integration team is really high, and there's not a lot of problems in production, or very few. So from a quality point of view, this process works. Now, you could say that, well, that's true, but if there were fewer defects introduced, if there were fewer defects present in the software when it was given to the independent test team for system integration testing would be faster, and so that would basically aid the agility of the organization, because they could get the software into production more quickly, and that would probably be true. So, you know, in this model, you could modify it and say, you know, we want to have an independent test team involved in the system test, and maybe even the component integration test. So Maha says there's a strong echo. I haven't seen this from anybody else or heard any other reports of an echo. One of the things that can cause an echo is if you've got a microphone on at your end and it's on, sometimes the audio settings can be such that you're basically picking up the sound and looping it back. Now, it might sound a little hollow here. I'm not in a professional sound studio. I'm in my office, and so there is going to be some amount of that sort of echoey sound. I can't really justify building an anechoic chamber to do webinars out of. A question for Bill, from Bill here. He says, in talking about quality COP, should code inspections be the responsibility of the development team or the QA/test group? Well, I think they could be run by the QA or test group. I think that would be okay, and I don't think that necessarily creates a quality cop scenario. I think it's more a matter of you know, are you approaching that from a service point of view, or are you approaching it from an enforcement point of view, right? I mean, the Australasian test group that I've mentioned a few times in this presentation, they're responsible for the for leading the requirements reviews and the design reviews, but that's a service that they're providing. They're not there saying, you know, we're gonna enforce one outcome or the other. That's that everybody's agreed that there will be requirements reviews, or if there are design documents, those design documents will already be reviewed. That's baked into the process. So it's not the QA manager coming along and saying, you have to do those reviews, you know, otherwise you're a bad person, I'm going to tell on you. It's just that the project managers are saying, well, we've got these work products, they have to be reviewed. Cool, I don't have to worry about organizing it. I'll have the QA group organize it for us, because that's what they do. And that's one of the services they provide. So, you know, you could have code reviews be, or code inspections, depending on how you approach it, be a service provided by the test team. Now, I think in addition to it being a service and the testers needing to be service-oriented, of course, they have to be qualified to participate, right? You can't send someone in to be a moderator in a code review when they don't know how to read the code itself. I just think that's you know, that's going to make it very difficult for them to contribute effectively, even as a moderator. I think you really want to have people that are competent. I mean, part of it is you know, being able to contribute, being able to read the stuff. The other parts of it are respect. You know, I mean, the moderator is in a review is the leader of the meeting there, and they have to be respected, and they're not going to be respected if they don't really know what's going on. Let's see. Joshua says, why did you suggest test leads as the ones to run the requirements reviews? They don't necessarily have to be leads. I mean, I think they could be any experienced, qualified person. I think there is, you know, when you're talking about running a review meeting, there is a certain level of experience that you want out of that person, a certain level of seniority that I think you want. Again, this goes back to the credibility thing, but I mean, I think it could be any number of people in the test group. It does not have to be a test lead. I think it just should be whoever's most qualified to understand and contribute to a review of that particular work product. Tom asks, can you please speak to specific issues of effective collaboration between test and development and project management when an independent test team is used? Oh boy, yeah, that's a big topic. I could just be like its whole own webinar, couldn't it, Tom? So part of this is again, service orientation on the part of the test team. Right. So the project management team, if you've got like a sort of a PMO and then development teams and they're working for development managers and so forth, if that's sort of your organization, then your independent test group is providing services both to the PMO and specifically the project manager in charge of that project, and to the developers and the development manager who's working on development managers, perhaps, who are working on that project. So, you know, identify the different stakeholders from individual contributors on up, and what services they receive from the independent test group. Then, you know, work with them to say, okay, you know, what would it mean for us to be effective and efficient and to satisfy you with the way that we're delivering on these things. And you know, again, really, you know, a service-oriented approach. And this, I would say, this was like one thing that jumps out at me is thinking back of independent test groups I know that have failed versus independent test groups that I know that are like really successful and have been in place forever. That service-oriented approach is really what makes the difference. Now, if there's problems collaboration-wise between development and project management, I'm not sure there's a whole lot you can do about that. It is obviously going to be a huge problem for you because that will manifest itself as bad stuff getting delivered to you. But I think you in that situation you have to sort of try to act as effectively and professionally as you can in that sort of scenario. So Shane has an interesting question here about this slide, the model. Yeah, this guy says, with system integration testing happening after the project, is the project team still alive? They might be disbanded and on to other things by the time a defect is found. Well, that would be a problem. I mean, obviously, at least enough of members of the project team have to be kept assigned to the project to fix bugs. Now, with the different release models that we've seen, there are different ways of dealing with that. But yeah, I mean, if you just move everybody off and assign them other work, and they're working on completely other projects, and now they get interrupted, that is going to be a big issue. So, and it's not unusual. This is a manifestation of a common testing worst practice, which is to plan testing on the assumption that there will be no bugs found. So there definitely has to be some level of support available. Now, of course, if the project is following some sort of agile approach and they're still, they're on to the next iteration, then again, they need to, some percentage of their time needs to be set aside to supporting that testing outside of the sprint. And we've got clients that have various ways in which they do that. They basically tell people a certain percentage of your activity is devoted to this kind of thing or that kind of thing. And so there are ways to do it, but it definitely does have to be done, and it has to be driven by a realistic expectation about how many person hours of bug fixing effort are going to be required. And that, of course, is a function of what's the defect detection and defect removal effectiveness of the earlier levels of testing, such as system test and component integration test, which gets back to Stefan's point earlier about, maybe these should be owned by an independent test team. Well, yeah, especially if there's going to be problems getting sufficient developer resource later to fix defects found in system integration tests, maybe they should. So, good point. Let's see. Tracy says, thank you for your time today. Always interesting. Thank you for the kind words. Oops. I'm sorry about that. Not sure what happened there. Glad that these are a useful investment of your time, Tracy. Let's see. Mercedes says, we have no problems with sound. So it does sound like that's kind of isolated. Yeah, if you do have sound problems, check your audio settings first, because I think unless everybody's saying they're having problems, it's usually some configuration specific. Excuse me. Tom asks another similar question. Well, let me get to Bill's follow-up question here first. I'll go back to Tom's follow-up. So Bill says, okay, so if I treat it, code inspections, as a service being offered, the QA can facilitate the code inspections, and I'd say yes. I think that's fair. Again, it has to be a service not an enforcement, and it has to be something. It has to be a service that you're competent to offer, which means being conversant in the code, the coding standards, and so forth. So now to Tom's follow-up question, can you please speak to issues about service contract between project team and independent test team? Okay, that's another good one. I mean, so one of the things that you sometimes see is this idea of SLAs, or service level agreements, right? And those would be defined around areas like response time, right? If development has a question about a defect and they need additional information, what's the response time? Will be an example of that. If project management needs an analysis of defect trends, you know, how long would it take to get that? You know, those sort of things. So you can go that route. You know, you can go with the, you know, you've got defined SLAs, and certainly in some cases that makes sense. You know, when the independent test team is an outsourced service, you know, to some extent, like we have one client where the managers are the managers in charge of the testing for the different programs are employees of the company, but they're using outside testing service providers to provide pretty much all the other staffing. Now, in that case, I think having those kind of measurable SLAs makes a lot of sense, you know, and you want to have that as part of the contract between you and the service provider. For in-house situations, you know, if you need it, then do it. But I mean, if you don't need that kind of formality, and you can go with just, you know, you've got defined services and you have objectives and you've got effectiveness and efficiency metrics for those objectives. You measure those periodically, quarterly, monthly, whatever. You converse regularly with your stakeholders about the services that you're providing to them and what you can do to improve them. You know, I think that's I think that will probably work. And that's so much head and shoulders beyond what most independent test groups do. That kind of active engagement with their stakeholders. I think that sets you that puts you in the best practices realm, regardless. And if you find that you need to go beyond that, then, you know, by all means do. But I think most of the time you won't. So let's see, we've got a question from Geetha. Should unit tests be done by the dev team only? I know some organizations that have QA teams write and execute unit tests. What are the pros and cons of QA groups writing unit tests? Well, boy, I don't know how to give this a relatively succinct answer in a short period of time. So, I mean, one of the issues, well, you know, obviously, anytime you have an independent test group involved in the testing, they are objective, they are unbiased. So, you know, you've got that going for you. You're not bringing the assumptions to it. Now, some of the disadvantages are, one is, of course, the test group has to be very conversant in the programming language that's being used. You know, able to actually read, understand the code, and formulate a set of tests from the code. Another disadvantage is that there could be some ramp-up time involved that might or might not be valuable in learning how a particular piece of code works. They'd end up asking the developer a lot of questions about it, and the developer might say, you know, this is a distraction to me. Now, of course, you could look at that and say, well, that's kind of like a pair programming sort of thing. It's a peer review that's going on, and maybe the developers and the testers should work side by side, one developer, one tester. And the developer is focused on writing the code, and testers working with that person on, you know, effective tests for it. And maybe that's a way to go. I think most of our clients have stuck with the model of unit testing by developers, component integration testing, a joint activity by developers and testers, though I'm going to come back to that in a minute. And then system testing, system integration testing, more done by the independent testers. And I think it's not just a tradition, it does seem to be a good idea. Now, component integration testing, you could say, well, that often doesn't happen, and that's true, and that's a problem. I'd say that if that's not going to happen and it needs to happen, it'd be better if it was done to some extent by QA rather than not at all, even if they can't get developer support. Let's see, Joshua had a follow-up question. The question was more focused on why testers, but he's left, so I can't get clarification on that. So I'm not sure what that was. Let's see. So Tom said, sorry, and I'm not sure what you're sorry for. And so, those are great questions, Tom. Thanks for asking them. Okay, so Shane, Shane has an interesting follow-up to his earlier question about will people still be involved after the project has come to a close, as it were. He says, for instance, Project 2 has a time gap before SIT starts. So yeah, you see that here, and you see that here. So yeah, that's, again, you know, this agile versus sequential life cycle model matters here, because if this is being done with an agile model, then all that's happening is that these guys are on to the next iteration, right? Or any sort of iterative model, they're on to the next iteration. They just have to be available to fix defects. If it's sequential, yes, they might be reassigned to something, but still, there'd have to be some amount of competent development resource assigned to support the system integration testing as it was going on, because otherwise, without that, you're going to have, you know, no one's there to fix the bugs, and someone gets surprised by, well, we found a bug in code that you wrote. The person's like, well, yeah, but I'm working on this other project now. I can't fix bugs with one hand and write code with the other. So it does have to be planned for. Let's see. Niraj asks, will it be a good practice to estimate for communication delays and wait time due to showstopper defects? Is there any industry standards available for this? How to approach this? I did a presentation on test estimation webinar, and it's recorded, so you can go listen to that one, and I think you know, give you a lot more detail on this. But yes, I mean, the short answer is yes, you do need to include defects and other kinds of blocking / delaying events during testing as part of your as part of how you estimate the duration and effort associated with test execution. Generally, what you want to build is some sort of model that allows you to model the number of defects that are going to be found based on what have typically been found in past projects, and then use that model to try to estimate how long it's going to take to grind all those bugs out. So yeah, you do want to do that. I would recommend that you go take a look at that webinar. There's also an article out on the website, either on the basic library page or the articles page, that talks about this as well. So yeah, it's a big issue. Okay, well, we are Niraj says thanks for addressing that. It helps. Good, you're welcome. Good luck finding the webinar and reading the article, and if you've got further questions, we can discuss them on my blog. So to close this session, let me just tell you a little bit more about the resources available through RBCS. We do these free webinar sessions once a month. So you check the website to sign up. If you want a special webinar presentation for your company only of this webinar or any other topic, contact us by sending an email to info@rbcs-us.com, or you can contact us via our website. If you don't already receive our free newsletter, sign up at rbcs-us.com. This will get you valuable discounts on consulting and training services, and a regular newsletter that includes a featured article on software testing and quality, and news about what RBCS and our partners are doing. We are on Twitter at RBCS. We're on Facebook at RBCS-INC. Remember to check your email over the next couple of days. You might have won the free e-learning. You were registered just by showing up here today, so you know, check the email. My blog is rbcs-us.com/blog, so you can post comments on any of the material that's already out there. There is quite a bit. Or email me if you have a topic you'd like to discuss. Send an email to info@rbcs-us.com. include the word blog somewhere in the subject line to help me know where to address it. But generally just know that if you send me a question about this webinar or anything else, then as soon as time allows, the way I deal with those is just by posting them on the web or posting them on the blog, so you get the answer there along with other people, because usually people have similar questions. We've got our digital library where these recorded podcasts, webinars, etc. are available there. So feel free to check that out. Oops, excuse me, I'm having a technical difficulty here. You can subscribe to the podcasts on iTunes. Enter RBCS Podcast into the search string on the iTunes Store. You can see videos and recorded webinars on YouTube. Just subscribe to the RBCS channel on YouTube. So lots of free stuff available out there. As I said, I've got a couple ebooks that will be coming out shortly, so watch for those. We offer these free, and in the case of the ebooks, almost free resources as a service to the software testing community, because at RBCS we are a not just for profit company. This concludes today's webinar. I want to thank you all for joining us on this first webinar of the year. Hope you all had a great holiday, and hope you all have a very successful 2012. And then I see you all on 11 more webinars coming up. Goodbye.